Hello, in this video, I will talk about the implementation of the merge sort algorithm. Merge sort is one of the most efficient sorting algorithms out there. It is a great example on the use of divide and conquer in computer science. Merge sort takes a list of numbers and sorts them by breaking down the list into smaller sublists until each list contains one single element. In other words, it divides the problem into smaller subproblems, solves these subproblems, and then combines the results. Merge sort is usually implemented using recursion, since recursion is defining a big problem in terms of smaller versions of itself. In order to know or to see how merge sort works, we will take an example of a list of unsorted numbers and sort them using the algorithm.
Let us take this unsorted array as an example. 5, 7, 3, 0, 2, 9, and 1. So at this first stage, merge sort will divide the array into two subarrays. This is the first subarray, and this is the second subarray. Next, we will have four subarrays. So the array above will be divided into two smaller arrays, and this array will be divided into these two subarrays. And here we will have 7 subarrays, which are the number of the elements in the list, in the original list. Now bear in mind that this number here, or this element here, has already reached the base case at this level. So now at the final level, all the arrays are arrays of length 1. Now these smaller sublists will be merged again into bigger lists, but this time the bigger lists are sorted. So here you have 5 and 7 in a smaller list or in a bigger sublist, but are sorted. And then you have 0 and 3 merged together in a sorted list of size 2. We have the same for 2 and 9. And we have this small list containing 1 at the end, and it is still waiting to be merged with the list on the left. Next, the first two lists containing 5 and 7 and 0 and 3 will be merged into a bigger list, but that is now sorted, containing 0, 3, 5, and 7. And the two lists that are at the end will be also merged into a bigger sorted list. And at the end, the two lists will be merged into a bigger list that is also sorted. So this is a high-level view on how merge sort works. And it doesn't look so complicated. Actually, the code is a bit less straightforward. But before taking a look at the code, I will talk a bit about the complexity of this algorithm. In order to calculate the complexity of the algorithm, we need to take a look on how many merge operations are taking place. At this level, we have merge operations happening between 7 numbers, the same at this level and the same at this level. So to generalize, we can say that we have at each level merge operations happening between n numbers. But how many sets of merge operations are taking place? Actually, this is the number of times the size of the list is divided over 2 in order to reach a list of size 1. So the number of times we divide a number n over 2 in order to reach a list of size 1 is actually log 2 of n, or log base 2 of n. But for simplicity, we write it as log of n. So we have n merge operations happening for log n times. Therefore, the complexity of the algorithm is n log n. This algorithm is implemented using two functions. The first main function, merge sort, is recursive and it takes an array of number, a starting index, and an ending index. In order to illustrate how the code works, let's take an example of an unsorted array. So let's say we have 5 or 8, 5, 1, 0, 6, 7, 4, and 3. The first time the function is called, our starting index will be here, and the ending index will be here. So it would be 0 for the starting index and n minus 1, or the size of the list minus 1 for the ending index. A middle index is calculated here. So in this case, the middle index would be here, and the merge sort function will call itself recursively twice, once from the starting index to the middle index, and another time from the middle index plus 1, which is here, to the ending index. And this process of recursion will continue until we reach the base case, where the starting index is not less than the ending index. Actually, they will be equal. In that case, the size of our list would be 1, and in that way, we ensure that we cannot go further and break down our list into smaller lists. So the algorithm will keep on breaking down the list until having smaller sublists of size 1. This merge function takes an array of integers, a starting index, an ending index, and a middle index. Also keep in mind that this merge function works on the same original array of size n, but each time the starting index, the ending index, and the middle index are different. The main task of the merge function is to merge two sublists that are adjacent in the original list. It does that by creating indices on the sublists. The first index is an index on the sublist on the left. The second index is an index on the sublist on the right. And the third index is the index on the list that will be the result of the merge of the sublist on the left and the sublist on the right. The merge logic takes place here in this while loop. So I will use an example of two small sorted lists that we will merge them into a bigger list that is sorted. So let's take 2, 3, and 6 here, and 4, 5, 8, and 9 here. Now, here we have an index I that's pointing here, and an index j, or an integer j, that's pointing here, and an integer k that will point to the list that's the result of the merge. Now, we will compare here the first two elements. So we have 2 and 4. So 4 will go here as the first item. Sorry, it will be 2 because it's less than 4. And since 2 will go here, then we increment this index and it will point here. Once we go out of bound in any of these lists, we go out of this while loop because we will not be satisfying this condition. But we still have 8 and 9, so we move them into the result using this while array. And the first while array is in case we still have elements in the first list that need to move into the result. And at the end, we still have one step to perform, which is we want to take the result from the temporary array. So this array is temporary here. It's local to this function, but it contains the sorted sub-array or the sorted result. We want to copy this sorted result into the original array here by looping through the original array and the result and copying the elements.